Hello. For the past several years, researchers at Virginia Tech have been developing resources for experimental research in wireless communications. I'd like to invite you to learn more about these resources and see whether they might be useful for your own work as an instructor, student, or researcher. The testbed and software that we will see provide exciting opportunities for hands-on engaging educational experiences, as well as research in wireless communications, including new and rapidly growing or changing technologies and applications such as spectrum sharing, spectrum management, cognitive radio, and many others. We are grateful for the support of several sponsors who make this work possible. The work described here supports two major goals. The main educational goal is to enhance instruction in wireless communications through demonstrations and remote laboratory exercises. The resources we have developed also support research in wireless communications, including advanced topics, some of which are mentioned here. Through this video and others, as well as the tutorials and exercises that we are developing, we hope to encourage people who are interested in wireless communications to use the resources we have developed. Tutorial users will become familiar with the resources as well as fundamental and advanced concepts. Advanced tutorials prepare users to carry out their own original experiments. As we introduce these tutorials, we will be gathering feedback from users to help improve the underlying hardware and software, as well as the tutorials themselves. We will take a high-level view, providing a brief description of major components of the wireless communications research and education infrastructure. These include CoreNet, an Internet-accessible testbed based on software-defined radios, or SDRs. CoreNet is capable of running popular SDR software, including GNU Radio, RedHawk, and others. In addition, we have developed some custom software to promote educational and research use of CoreNet. CoreNet 3D lets a user interact with CoreNet, displaying the radio spectrum and enabling interactive control of radios using a standard web browser. The Cognitive Radio Test System, or CRTS, is open-source software that manages radio experiments. The experiments can include cognitive or spectrum-sharing radios, and will soon be able to include other radios and wireless networks. Finally, we are developing an open-source Spectrum Access System, or SAS, a system that manages use of shared radio frequencies by issuing spectrum grants for a specified period of time, location, and frequency range. The SAS also monitors the frequencies to ensure that they are used correctly. The CoreNet Testbed, CRTS Experiment Management Framework, and CoreNet 3D web-based spectrum visualization and radio control software enable interactive learning as well as experimentation. Interaction can be synchronous using CoreNet 3D or asynchronous. In the asynchronous case, users can program or configure radios that will operate autonomously during experiments on CoreNet. In the next few minutes, we will take a brief but closer look at each of the components shown in this diagram as well as the open-source SAS. CoreNet, the Cognitive Radio Network testbed, consists of over 40 software-defined radio nodes, all accessible by Internet. Currently, each radio is connected to a server that performs processing. Several additional servers have specialized management functions. The radios in CoreNet are located above the dropped ceiling on 4 floors of Kelly Hall, a research building on Virginia Tech's Blacksburg campus. CoreNet 3D consists of front-end and back-end code that enables a user to interact with a testbed such as CoreNet. The user interacts with the front-end code through a web browser, while the back-end code interacts with the radio nodes that make up CoreNet. CoreNet 3D displays the testbed layout, including SDR node locations and status, displays the radio spectrum at selected frequencies in 2- and 3-dimensional formats, and enables remote control of radio parameters if used with suitably configured radio waveform software. CRTS is an open-source experiment management system that allows users to configure and run experiments that include primary and secondary spectrum users, whether communication systems or radars. Experiments can also include a spectrum access system or systems. CRTS currently works with the custom flexible OFDM wave for Virginia Tech's Spectrum Access System is an open source system that manages and monitors use of shared radio spectrum bands. The SAS issues spectrum grants to users, allocating the radio spectrum in time and space as well as frequency. A SAS is the FCC's preferred approach to spectrum sharing at 3.5 GHz, and it could be used at any. Thank you for spending the last few minutes with us. We hope that you will find the infrastructure we have described useful for your own efforts, whether in teaching, learning, or research. Please contact us with any questions.